A qualitative analysis means that you want to know what are the components or what are the metals which are present in that water sample. So when we will perform a qualitative analysis, so we will know that this specific water sample have copper, it has nickel, it has zinc, and it has some organic content. So this is a qualitative analysis. However, when we talk about quantitative analysis, so that determines the relative amounts of each substance in numerical terms. For example, we will take the same example that we have a water sample and we know that it has copper, nickel, zinc and organic content. So how much amount of each copper, nickel, zinc and organic carbon or organic content is present in the water? So that can be determined through a quantitative analysis. So if we use some advanced technique and analyze our water sample, and we know that sample contains, for example, 5 milligram of copper, 8.2 gram of nickel, 22 gram of zinc, just suppose values, and it contains around 5 milligram of dissolved organic content. So what is this? This is a quantitative analysis in which we have determined the exact quantities of the components of the sample. So this is the main difference between a qualitative analysis and a quantitative analysis. In qualitative analysis हम ये देखते हैं कि हमारे पास जो सैंपल है उसके अंदर क्या क्या चीज़ें मौजूद हैं, और क्वांटिटेटिव एनालिसिस में हम ये डिटरमिन करते हैं कि उस सैंपल के अंदर क्या क्या चीज़ मौजूद है और कितनी कितनी अमाउंट में मौजूद है. सो दिस इज द बेसिक ऑफ क्वालिटेटिव एंड क्वांटिटेटिव एनालिसिस. वन मोर टर्मिनोलॉजी जो कि हम बहुत ज़्यादा यूज़ करेंगे इन आवर लेक्चर इज द टर्म एनालाइट. सो व्हाट इज एन एनालाइट? सो एनीथिंग which is present in a sample which we are going to determine or analyze is called an analyte. Okay, so I just wanted to give you the brief idea what we mean by analyte in a analytical chemistry or in a quantitative analysis. Okay, so in quantitative analysis, or when we talk about different quantitative analytical methods, so you should remember one thing, that all the quantitative analysis involve two type of measurements. Number one, it is the mass or the volume of sample which is being analyzed. So we take in the last slide, in the previous slide, an example of water analysis. So same we will consider here. Okay, the first type of measurement is actually the amount or the volume of sample that you are going to analyze. For example, you are taking 5 ml of a sample or 10 ml of a sample. So the first type of measurement will be the amount of sample which you are going to be analyzed. And the second measurement will be any quantity which is proportional to the amount of analyte in the sample. So did you get it? Okay, let me explain in a simple way. So पहले आपने जो मेजरमेंट है वो है आपके पास कि आपने सैंपल कितना लिया. आपके पास फॉर एग्जांपल 1 लीटर सैंपल है, आपने उसमें से 5 ml ले लिया फॉर एनालिसिस. दिस इज द फर्स्ट मेजरमेंट, दैट हाउ मच सैंपल यू आर गोइंग टू टेक फॉर एनालिसिस. एंड देन you have to actually analyze and quantify the exact amount of metal ions and organic content in the water sample. So how you are going to measure it? For example, if you are want to measure copper in the sample, so for you can analyze it by spectroscopic method. And in spectroscopic method, what you are going to do, that you are going to add some chemicals which make some complex with copper, and then you check their absorbance. So in that case, the absorbance is the quantity which we are talking about, which we are talking here, that is the second measurement is of a quantity which is proportional to the amount of analyte in the sample. So in spectroscopic analysis of copper, so we will measure the quantity of copper or that analyte through the absorption of light. So here that quantity is light, but if we want to analyze that copper present in the water by ion chromatography, for example, so here that property will be the change in the electrical conductivity. So in ion chromatography we will analyze the amount of analyte, which we, in example taking the copper in the water sample, so we will analyze or quantify the amount of copper through analysis of the change in the electrical conductivity of the sample in the ion chromatography column. So what we mean here कि जब आप एक quantitative analysis कर रहे हैं, so you have to have two things. First is the amount of sample, and second, when you want to know the composition of that sample कि उसके अंदर कोई चीज़ कितनी मौजूद है, so then you have to decide कि आपने कौन सी जो है उसकी कैरेक्टरिस्टिक है जिसके थ्रू आपने उस एनालाइट को जो है वो एनालाइज करना है या उसको क्वांटिफाई करना है. एंड डिपेंडिंग कि आप कौन सी क्वांटिटी यूज़ कर रहे हैं, कौन सी कैरेक्टरिस्टिक यूज़ कर रहे हैं, दैट कैन बी, फॉर एग्जांपल, दैट कैन बी वॉल्यूम, दैट कैन बी मास, दैट कैन बी इंटेंसिटी ऑफ लाइट और इलेक्ट्रिकल चार्ज, as we discussed, it can be absorption of light, it can be conductivity. So depending कि आप कौन सी characteristic और quantity जो है वो use कर रहे हैं for that analysis, so on the basis of that quantity we divide analytical methods into many categories. For example, first we have gravimetric methods. So what we analyze in gravimetric methods, how we quantify the analyte in the gravimetric methods. So in gravimetric methods we measure or determine the mass of the analyte either directly or through indirect way. For example, we have copper and we will precipitate copper by adding some chemicals, and we will collect that precipitate and we will measure the mass of the copper precipitate, whatever the compound we are using. And then by weighing by the mass of that precipitate we can analyze how much copper was present in that water sample. So such kind of methods which involves measurement of mass are known as gravimetric methods. Second, we have volumetric methods. So here we measure the volume of a solution which actually have the ability to react with the analyte of our interest. For example, we are considering the example of a water sample. So to determine the amount of copper through volumetric method, so we will add some solution which have some specific reagent that reacts with water and form some compound. So we will add that solution and we will make some endpoint. For example, we will see that we will keep adding until there is a color change, and then we can see that all of the analyte has interacted with that solution or that reagent, and then we record how much volume was required, and by using that volume we can actually quantify the amount of copper present in the sample. So such kind of methods in which we use the volume of a solution or a reagent or for quantification purpose are known as volumetric methods. Third, we have electroanalytical methods. So in electroanalytical methods we measure some other properties, electrical properties, for example potential, current, resistance, or quantity of electrical charge. So we use these electrical properties for quantification of a analyte in our sample. So all those methods which use electrical properties for quantification are known as electroanalytical methods. After electroanalytical methods, the fourth one here we have spectroscopic method. So spectroscopic methods are those which quantify analytes in a sample based on the interaction of electromagnetic radiation with analyte atoms in a solution. For example, as we discussed before, that we use the absorption of light, or we can use the transmittance of light to determine the quantity of a specific analyte present in the sample. So in spectroscopic method we use basically the interaction of electromagnetic radiation with analyte of our interest. And then we have certain other methods which use different quantities for the quantification purpose. For example, mass to charge ratio can be used as it is used in the mass spectrometry. Similarly, rate of radioactive decay can be used for the quantification. We can use heat of reaction, we can use rate of reaction for quantification purpose. Similarly, we can use thermal conductivity, we can use optical activity, or in some cases we can use refractive index for quantifying a specific analyte in the sample. So ये different तरह के methods हैं which we can use for the quantification or a quantitative analysis. So depending what kind of sample we have and how much accuracy we require, or what kind of results we want to get from analysis, we decide what kind of method is appropriate for a specific analysis. Now we will overview typical quantitative analysis. So quantitative analysis जब हम किसी चीज़ को quantify करते हैं किसी भी sample में, so it have many steps. So the first step is always choosing a method, that what kind of method you are going to use for analysis, and then how you are going to acquire the sample for analysis. And in some cases we have to process the sample before analysis, and in certain cases the fourth step is eliminating the interferences. So sometime there are some kind of interferent ions present in the sample that we have to remove before we perform the analysis. And next step is the calibrating and measuring concentration. And after we measure the concentration of analyte, the sixth step is basically we just calculate the results, and last we evaluate the result and see how reliable our analysis is. So these are basically the 7 steps which are involved in a typical quantitative analysis, and we will discuss all of them in detail in the coming slides. So let's start with our first step in the quantitative analysis. First step of quantitative analysis is always the selection of method and how we choose a method. Sometimes it's a tricky choice, you have to have some experience before you can choose a good method for your analysis. So first step or first parameter which we have to consider before we choose a method is the level of accuracy we require for the analysis. So basically आपने कोई चीज़ जब एनालाइज करनी है, क्वांटिफाई करनी है किसी सैम्पल के अंदर, सो उसको एनालाइज करने के लिए कई पॉसिबिलिटीज़ हो सकती हैं. देयर आर मल्टीपल ऑप्शंस और देयर आर डिफरेंट मेथड्स टू एनालाइज और क्वांटिफाई द सैम्पल. सो बिफोर वी एनालाइज और विद स्पेसिफिक मेथड वी हैव टू नो कि हमें कितनी एक्यूरेसी चाहिए, हम किस चीज़ के लिए एनालिसिस कर रहे हैं, उसकी एप्लीकेशन कहाँ पे है. So depending on the level of accuracy required, we decide the method. And the second important criteria जो पे determine करता है आपका method for analysis, that is time and money. So there are different techniques which require a huge amount of time, and they are very expensive as well. And while the same analysis with less accuracy can be performed in less amount of time and with less money being used. So it also depends के what kind of sample you have for analysis and उसके ऊपर आप कितना time and money जो है वो spend कर सकते हैं. So that actually determine help you determine the type of method for the analysis. And another consideration that is related to actually economic factor is the number of samples that we have to analyze. So the number of sample is another very critical criteria which help us decide the method which we are going to use for analysis. For example, if we have a sample which for example we have only one sample which we have to analyze. So for analysis of one sample हम एक ऐसा method use करेंगे कि जिससे हमें time कम लगे. For example, we can determine in 1 hour or 2 hour, and which for that ऐसा method जिसके लिए हमें कोई preliminary जो है वो treatment ना करनी पड़े. But if we have many samples, for example we have 25 samples or 30 samples, so then maybe we can use method के जिसके अंदर we have to use some calibration, we have to use some internal standards. So for large number of samples we can afford that, but if we have very small number of samples, so then it can result in the wastage of time and money. Let's take an example of water sample analysis. So जैसे हमने पहले भी डिस्कस किया कि हम कॉपर एनालिसिस करना चाह रहे हैं, कॉपर की अमाउंट को वाटर के अंदर. सो अगर हमारे पास एक सैंपल है कॉपर का और हमने उसको एनालाइज करना है, सो एक तो मेथड ये है कि हम उसको सिंपल किसी कम्प्लेक्सोमेट्रिक टाइट्रेशन के ज़रिए कर लें, सो वो हो जाएगा, या हम उसकी एटॉमिक अब्जॉर्प्शन के थ्रू कर लें, although it is an expensive option, but it will require some little time. Or we can determine it by ion chromatography. So जब हम ऐसे मेथड की बात करते हैं, फॉर एग्जांपल आयन क्रोमेटोग्राफी की, फॉर एग्जांपल यू हैव टू एनालाइज 1 सैंपल और 20 सैंपल, सो देयर इज सम प्रिलिमिनरी ट्रीटमेंट. फॉर एग्जांपल ईच एंड एवरी सैंपल आपको उसको पहले फिल्टर आउट करना है 0.45 माइक्रोन से, एंड देन आपने उसको एसिडिफाई करना है, बिकॉज आपका जो आयन क्रोमेटोग्राफी कॉलम है वो ओनली 3 to 4 pH अगर उससे लेस हो तो आप उसको एनालाइज कर सकता है. सो देन जो आपका क्रोमेटोग्राफी कॉलम है आपने उसके अंदर पहले कैलिब्रेशन भी करनी है, आपने कैलिब्रेशन कर्व ड्रा करनी है, देन आपने इंटरनल स्टैंडर्ड रन करने हैं. सो दिस प्रिलिमिनरी स्टेप मे टेक 10 to 12 आवर्स बिफोर आप अपना सैंपल जो एनालाइज कर सकें. सो इफ़ यू हैव ओनली 1 सैंपल एंड उसके लिए आपको 12 से 14 घंटे जो है वो पहले इंस्ट्रूमेंट को कैलिब्रेट करना पड़ रहा है और उसको रेडी करना पड़ रहा है जस्ट 1 सैंपल के लिए. सो इट्स रियली अ टीडियस जॉब. सो यहाँ पे इफ़ यू हैव सच ए केस, तो आप ऐसा मेथड यूज़ करेंगे कि जो कि ईजी हो और जिसमें ये वाले स्टेप ना करने पड़े. बट इफ़ यू हैव फॉर एग्जांपल मैनी सैंपल 20 odd or 70-80 सैंपल्स एंड यू नीड हाई एक्यूरेसी, देन मे बी यू विल प्रेफर कि आप आयन क्रोमेटोग्राफी से एनालाइज करें. मे बी आपको उसके लिए जो है वो 18 घंटे या 19 घंटे के प्रिलिमिनरी ट्रीटमेंट करना पड़ेगा. बट द थिंग इज it will give you a more accurate analysis as you have many samples. So that number of sample also help us in deciding what sample we have to use. So last another factor is the complexity of the sample, and for example the number of components present in the sample. So if you have a sample which you have to analyze, and before you choose the method you have to know that how many interfering ion can be present in the sample, or how many components are present in that sample. So that complexity of the sample also help you decide the desired method. फॉर एग्जाम्पल अगर आपके पास एक सैम्पल है और आप उसको सिंपल मेथड से कर सकते हैं, अगर आपके पास 1 या 2 एनालाइट हैं, so you will choose that simpler method. But for example you have a sample which have 10 or 12 different analyte that can or may interfere in the analysis, and you can get the false or wrong information. देन यू चूज़ अ मेथड कि जो कि सिलेक्टिव और स्पेसिफिक हो फॉर ओनली एनालाइट ऑफ योर इंटरेस्ट, एंड देन आप उस मेथड से जो है उसको एनालाइज करेंगे. सो दीज आर पैरामीटर्स एक्चुअली help us decide what kind of method we are going to use for a quantitative analysis. So the second step in quantitative analysis is acquiring the sample, कि आप sample कैसे लेते हैं, and this is one of the toughest step of quantitative analysis, especially when जब आपके पास sample जो है वो heterogeneous हो. Heterogeneous sample is that कि जिसकी में कंपोजिशन जो है वो इक्वल ना हो. इफ़ वी टेक अ सैम्पल फ्रॉम वन एरिया इसकी कंपोजिशन डिफरेंट होगी. इफ़ यू टेक अ सैम्पल फ्रॉम अनदर एरिया एंड इट्स कंपोजिशन विल बी डिफरेंट. सो इफ़ यू हैव अ हेट्रोजीनियस सैम्पल एंड देन वहाँ पे जो है वो टेकिंग अ रिप्रेजेंटेटिव सैम्पल. रिप्रेजेंटेटिव सैम्पल इज़ अ सैम्पल की जिसकी कंपोजिशन जो है दैट इज़ ऑलमोस्ट आइडेंटिकल टू दैट ऑफ बल्क. सो दैट सच सैम्पल वी कॉल के हमारे पास रिप्रेजेंटेटिव सैम्पल है. सो इट्स अ रियली डिफ़िकल्ट जॉब टू टेक अ रिप्रेजेंटेटिव सैम्पल फ्रॉम हेट्रोजीनियस सब्सटेंसेस एट द बल्क स्केल. हम एक एग्जांपल देखते हैं कि फॉर एग्जांपल जब आप माइनिंग करते हैं, सो दे हैव फॉर एग्जांपल दे हैव सिल्वर ओर, एंड जो माइन करते हैं उसके बाद दे हैव टू सेल देम फॉर इट्स फर्दर प्रोसेसिंग. सो suppose that we have 25 tons of silver ore, and if we have to purchase or we have to sell that one to some person or some company, so they will decide the price based on the content of silver present in that ore. कि अगर आपके पास ये है कि 25 टन है सिल्वर ओर है, अगर किसी ने ख़रीदना है उसको, जो भी बायर है जिसने उसको प्रोसेस करना है उसमें से सिल्वर को निकालना है, सो वो आपको प्राइस जो डिसाइड करेगा दैट विल डिपेंड कि आपके पास जो सिल्वर है वो कितनी अमाउंट है उस ओर के अंदर. नाउ द प्रॉब्लम इज़ कि जो हमारे पास वो जो ओर हैं, जो पत्थर जिसके अंदर वो मौजूद होंगे, सो दे हैव ऑफ डिफरेंट साइज. कुछ छोटे साइज़ के हैं, कुछ बड़े साइज़ के हैं. They have also some different colors. Some are lighter in color, some are darker in color, some have some other changes. So which means that amount of silver is not same or homogeneous in all of that bulk 25 tons of ore, and unless we determine the amount of silver in the ore, we cannot determine that how much it should cost. So taking a sample from such a bulk heterogeneous sample is a really tough ask. So in such a case, how we are going to analyze that 25 tons of silver? हम सारा तो analyze कर नहीं सकते. Definitely we mostly perform assay for और के जो है उसके amount analyze करने के लिए किसी भी metal का. So assay जो है वो mostly 1 ग्राम का होता है. So ऑलमोस्ट 25 टन्स है और उसमें से अगर आपने 1 ग्राम लेना है, दैट शुड रिप्रेजेंट दैट 25 टन्स. दिस इज़ अ रियली डिफ़िकल्ट टास्क. सो दैट शोज़ के हाउ इम्पोर्टेंट एंड हाउ डिफ़िकल्ट इट इज़ टू एक्वायर अ रिप्रेजेंटेटिव सैम्पल. हाउ बेसिक प्रोसेस के सैम्पलिंग की कैसे जाती है और उसका क्या प्रोसेस होता है, दैट एक्चुअली वी आर नॉट डिस्कसिंग इन दिस लेक्चर. सो वी विल हैव अनदर लेक्चर ऑन दैट टॉपिक. But we will take here another example of acquiring the sample. For example, we have a collection of specimens for biological sources. So for example, we are going to determine the amount of some gases in the blood. For example, we want to determine the amount of oxygen and CO2 in the blood of human present. When we talk about collection of samples from biological sources, it's a really difficult task actually, because जब हम एग्जांपल ले रहे हैं कि हम ब्लड में हमने ऑक्सीजन एंड कार्बन डाइऑक्साइड फॉर एग्जांपल उसके अमाउंट जो है वो डिटरमिन करनी है, एनालाइज करनी है. सो इट एक्चुअली डिपेंड्स कि जब आप ब्लड सैंपल लेते हैं और ऊपर से बाजू को जो क्लिप करते हैं, ये बांधते हैं, सो वो किस तरह से किया है, उसकी प्रॉपर वे में किया है यानी दैट एक्चुअली आल्सो डिपेंड द अब्जॉर्प्शन ऑफ these gases in the oxygen, so they can actually alter the our result. And for that case जो है वो there are specific protocols or procedures which are developed for sampling and transporting for biological samples. Because अगर आप थोड़ी सी भी उसके अंदर what we say बेहतियाती करते हैं तो then जो आपका results होंगे there will be wrong, जो है वो आपका actual जो है आप result उसमें से हासिल नहीं कर सकते. So that's why for clinical जो हमारे टेस्ट होते हैं we have to follow strict procedure for sampling and then storage or transporting. And overall जो सैम्पलिंग का जो प्रोसेस है, जब आप बल्क में से एक सैम्पल लेते हैं और उसको एनालाइज करते हैं, so that should be taken or should be carried out with maximum possible care, because it is said that the sampling is the source of greatest error in our analytical results or in a quantitative analysis. जो सबसे ज़्यादा एरर आते हैं किसी भी quantitative analysis से, they are because of the wrong sampling from the bulk material. So you are not getting the proper representative sample and the results you are getting are not the representative of the bulk sample. Until and unless कि we are sure कि जो हमने sample किया है that is representative of the bulk material, so we cannot until कि we are sure about that, so we cannot be sure कि हमारे जो analytical results हैं वो ठीक है. So reliability of analytical results actually depends on the reliability of the sampling procedure. So when we are doing analysis, so first we decide the method for which will be used for analysis, and then we have acquired a sample. So next the third step is processing the sample. In under certain circumstances there is no sample processing is required. For example, if you have you get a water sample from a canal or a river and you want to check its pH, so for that checking the pH आपको उसको कोई जो है वो प्रोसेस नहीं करना पड़ता. But there are certain cases in which we have to process the sample before we can analyze for a specific parameter. So we will discuss different examples so that you can understand what can be the different ways of, or what kind different processes which are required before the sample can be analyzed. For example, when we are trying to prepare a laboratory sample, we want to analyze some sample and in the laboratory, so we can have either mostly a solid sample or a liquid sample. So if we have a solid sample and suppose it is in the form of large pieces, so first process we have to apply is we have to grind it and make it in the powder form. So first process is to reduce the size. And another thing which is important is that when we reduce it to size, so it's become homogeneous. So it means the analytes are distributed evenly in the sample. However, when we have a powder which have a large surface area and small size, so if we put it in the environment open, so then it can absorb moisture, and it by absorbing moisture from the atmosphere, its composition can alter when we analyze the sample. So after we reduce its size, so we should either put it in some sealed container, or if we have put it for like more than a day or 2 days or more time after grinding, so before analysis we should heat it, so that if there is any moisture is absorbed from the environment, so वो जो है वो evaporate हो जाए. But in the liquid जो है अगर हमारे पास sample है, तो for that जो processing है that can be of different types. Liquid sample, there can be a problem that if we left these samples in open air, so they in open container, then the solvent may evaporate and it can change the concentration of the analyte. So to avoid the evaporation of the component, so they should be put in a container which are sealed. For example, we discussed an example कि जिसमें we discuss about the determination of gases in the blood of so for such cases, these gases actually can evolve or can be released from the blood if they are not put in the sealed container. So for such sample in which ये डर हो कि कुछ उसके components जो हैं वो evaporate हो जाएंगे, so for that we have to put them in the sealed containers. Another जो problem हमारे पास आती है that is insoluble compounds. कि जब we are going to perform some analysis and we need the analyte in the solution form, but there are some components के जो कि उसके अंदर dissolve नहीं होते जो भी हम solvent use कर रहे हैं. So what we have to do is we have to make them soluble in the solvent of interest. There can be different ways of making them soluble. For example, we can use some acid or base to dissolve the insoluble compound, or we can heat. But नॉर्मली प्रेफर ये किया जाता है कि जब हम कोई सैम्पल प्रिपेयर कर रहे हैं एनालिसिस के लिए, सो हम उसको बहुत हार्श कंडीशन ना दें, बहुत हाई टेम्परेचर ना दें, या क्योंकि उससे ये होता है कि उसके कई कंपोनेंट्स जो है देयर इज़ ऑलवेज अ फियर कि वो जो है वो ब्रेक डाउन हो सकते हैं, एंड दैट इफ़ देयर इज़ सम ब्रेक डाउन ऑफ सम कंपोनेंट्स, सो दैट मीन दैट वी आर नॉट गोइंग टू गेट द एक्यूरेट एनालिटिकल रिजल्ट्स. सो नॉर्मली इट इज़ प्रेफर्ड कि जो है वो उसको रूम टेम्परेचर पे किया जाए, बट इन माइल्ड कंडीशन. बट देयर आर सम केसेस इन विच देयर आर सम कंपाउंड विच कैन ओनली बी डिजॉल्व्ड एट हार्श कंडीशन, either by putting acid or the providing the high temperature. So it totally depends कि what kind of compounds you are dealing with. And there is another thing कि आपने एक आपके पास एक solid material है, you have to first dissolve it. आपने उसको dissolve कर लिया. Now क्या उसके अंदर कोई ऐसी प्रॉपर्टी है जिसको आप डायरेक्ट एनालाइज कर सकें विच इज़ प्रोपोर्शनल टू द concentration of the analyte? For example, we are going to determine the amount of manganese in steel, and if we have that ore of manganese and आपने उसको dissolve किया है, so can we directly analyze using a spectrophotometer? So the answer is no, we cannot determine it because it doesn't form any complex, that manganese which is dissolved by using the acid treatment. So what we have to do, we need to perform some other chemical process to change that analyte into a form which can be analyzed. For case of manganese, जब आपने उसको dissolve किया है using acid from steel, so जो manganese है it cannot be determined by the spectroscopic methods. So what we do is we first oxidize it into MnO4 negative. So by oxidation of manganese to MnO4, now we can determine it by using the spectroscopic method, because when we are talking about MnO4 negative, so हम उसको उसकी absorbance जो है वो measure कर सकते हैं उसको, because it has a colored solution. But without oxidizing manganese into the manganese oxide, हम उसको measure नहीं कर सकते. So depending what compound we are dealing, sometime we have to only dissolve the solid and directly analyze. In some cases we have to do some further chemical processes, and then we can analyze the analyte of interest. We have the step of eliminating interferences. So there, depending on what kind of sample we have, so there can be different interfering ions which interfere with the correct analysis of that sample. So that actually totally depends on the type of sample and kind of method we are using. Some methods are really specific. So if we have a solution which contain 3 to 4 ions, and that method is specific to one ion, then even though those other ions are present in the sample, so it doesn't interfere with the analysis. However, if we have a method which is not specific or selective to a specific compound, then we can get errors in the analysis. We can explain it with an example. For example, आपके पास जो एक water sample है जिसके अंदर आपने copper को analyze करना है, and but the sample जो है उसके अंदर copper भी है और zinc भी है. So अगर तो आप कोई ऐसा मेथड यूज़ कर रहे हैं कि जो सिर्फ कॉपर को डिटेक्ट कर सकते हैं और जिंक को डिटेक्ट नहीं कर सकता, तो इवन दो जिंक इज प्रेजेंट इन द सोल्यूशन, इट डजंट मैटर, बिकॉज आपका मेथड सिर्फ कॉपर को डिटेक्ट करता है. it is very specific and selective towards copper. But if that method is not specific and selective towards copper, और वो जिंक को भी डिटर्मिन कर सकता है. So what happen कि फॉर एग्जांपल आपके पास जो सैंपल है उसके अंदर 10 मिलीग्राम कॉपर है और 20 मिलीग्राम जिंक है. आप उसके अंदर कॉपर मेजर करना चाह रहे हैं, लेकिन जो आपका मेथड है वो दोनों को डिटेक्ट करता है. सो व्हाट हैपन्स कि आपके पास 10 मिलीग्राम कॉपर था, लेकिन जो आपके पास एनालिसिस करेंगे तो रिजल्ट में 30 मिलीग्राम कॉपर आएगा, बिकॉज जो आपका मेथड है वो जो 20 मिलीग्राम ऑफ जिंक है उसको भी डिटेक्ट कर रहा है, और आपके पास जो वैल्यू आ रही है वो 10 कॉपर प्लस 20 जिंक वो आ रही है, एंड आपका जो रिजल्ट है वो टोटली जो है वो गलत है. सो डिपेंडिंग कि आपके पास सैंपल क्या है और आपके पास किस तरह से कौन कौन से इंटरफेरेंट आए हैं, सो वी हैव टू फाइंड अ वे टू ओवरकम दोज इंटरफेरेंसेस. But it is a really difficult process, and there is no hard and fast rule that can be given for eliminating interference, and it totally depends the kind of sample you have and kind of instrumental technique or the methods of analysis you are using. Next step is the calibrating and measuring the concentration of the analyte. So as we discussed earlier, that measurement of x, which we talk x, that can be any property, so that is very important for the analysis of analyte. So that x can be a physical property or a chemical property. For example, we discussed earlier, like it can be an absorbance or it can be current or whatever. So here in that equation we know that C of concentration of analyte is directly proportional to the x or the specific property. If we take a spectroscopic analysis, we say that concentration is directly proportional to absorbance of the absorbance by the analyte. So K here is a constant, which is a proportionality constant, and it is a very important step, the determining of K in any analytical analysis actually. So that step is actually called as the calibration step. And in here we should know that the direct relationship or direct proportionality between an analyte and the property which we are using for the analysis is really important. And another very important thing is the reproducibility of that proportionality and the result. For example, you are performing some spectroscopic analysis, and उसके अंदर जो आपकी absorbance measure कर रहे हैं, and at that absorbance, in change in absorbance, if we have a higher absorbance, we say that the concentration of analyte is higher. If we have the low absorbance, it means the concentration of analyte in the sample is low. So this direct proportionality or inverse proportionality is very important for a specific sample for the analysis purpose. However, this should be reproducible. For example, if we perform one analysis today, and for example we have one molar solution and of specific compound, and it gives absorbance of 0.7, and next day we use the same solution and it gives absorbance of 0.2 instead of 0.7. So which means that analysis is not accurate because it is not reproducible. So we should check the reproducibility of the process, and unless it is reproducible, we cannot actually rely on the data. So reproducibility and direct proportionality of the concentration of analyte with that property or a specific characteristic which we are using for analysis is really important for the accuracy of our analysis. Now after we get the result, the next process is analyzing those results or computing or calculating those results. So we get different experimental data, which we call it the raw experimental data, and then we can compute or work on the data to get the some information from that data. For example, when we are using spectroscopy, So we are the values we are getting, or the data we are getting, is the absorbance value. So we have to process those values and convert that absorbance data to the concentration. And this is normally an easy step because of the facilities we have today, like computers we have, so they can compute the data in a very short period of time. So this step is not difficult during the quantitative analysis. However, the evaluating the results by depending how much reliable they are is very important in analytical analysis or in a quantitative analysis. So we have to determine how reliable our method is, or how reliable our results are for a specific analysis. And one of the method is that when we perform an analysis, so we use some standard, we put some internal standard along with the sample. So by that mean we way we can measure the difference between the standard values and our the sample value or the experimental value. And another way to ensure that our results are reliable is that we perform the experiments in duplicate or triplicate. So अगर हमने एक सैम्पल लेना है तो हम उसको 2 या 3 दफ़ा जो है उसको मेजर करेंगे और एवरेज वैल्यू जो है हम उसको यूज़ करेंगे. So that actually the measurement of uncertainties in सैम्पल एनालिसिस जो है वो हमें बताता है कि हमारा जो मेथड है वो रिप्रोड्यूसिबल है. इवन इफ वी हैव परफॉर्म्ड 3 टाइम्स, तो जो हमारे रिजल्ट हैं वो सिमिलर आ रहे हैं, जिसका मतलब है कि जो हमारा जो एनालिसिस है रिलायबल है, एंड वी कैन बिलीव जो हमारे पास जो रिजल्ट आए हैं उनको हम जो है वो ट्रू कंसिडर कर सकते हैं और करेक्ट कंसिडर कर सकते हैं. Were the steps which are involved in a typical quantitative analysis. So if we want to summarize this our lecture, so we will use this diagram. So this shows all the methods and steps which are involved in a quantitative analysis. So first is the selection of method. We select what method we are going to use for analysis, and the second step is the acquiring the sample. And after we acquire the sample, the third step is the processing of the sample. And in processing we have to see whether our sample is soluble or not. If it is not soluble, we mostly do some chemical dissolution and we dissolve and make it in the soluble form. And after we get it in the soluble form, we see that whether it has a measurable property or not. If it can be measured at that stage, so we move to the next step, or we bring some chemical change to make it to have introduce some measurable property. And then next step, we see if there are any interfering ions in the sample or not. If there are any interference, then we try to remove those interference or mask them. And after that, then we measure the property, any property we can be used depending on the sample. It can be gravimetric, for example, it can analysis, or it can be volumetry, or it can be spectroscopy. So depending on the sample, we can use whatever method we are using. So we measure those properties. For example, in spectroscopy we measure the absorbance, and after that we use the computer to calculate or compute the results. And we also determine the uncertainty in the analysis and determine how reliable our method is. So this is actually the overview of all a typical quantitative analysis की जब भी आप कोई quantitative analysis करते हैं, so कौन कौन से step जो है उसके अंदर जो है वो involve होते हैं. So this is another important slide for you guys. And these are the references which I have used in this lecture. So most of the materials from the book of Scrooge and West, Fundamentals of Analytical Chemistry, 9th edition, and some of the material was from the Analytical Chemistry, 7th edition by G.D. Christian and Dasgupta. I am going to share the link of these both of these books in the Google Classroom. So what you have to do is you need to study in detail about quantitative analysis, specifically from the book of Scooge. So that's why I haven't put many details on our lecture slides. So we have only bullets on the slide, and for the details you must consult with to the book of the fundamentals of analytical chemistry.